Okay, welcome back. We're now going to be looking at how to draw a position time graph and review some of the requirements for tables, observation tables, and also when we're doing graphing, what we can do with graphing. So I do want to emphasize this is just like an overview and give you an example here. So in this situation, we've got Surfing Bob, and he's driving home from work as his GPS unit is tracking his distance and time for 10 different intervals. So in fact, it's keeping track of his position. And the following table shows the data that was obtained from the GPS unit. So what we want to look at is the quantities that are in the table. So we've got position over here, and we've got time. So we have a table, a good heading would incorporate those two quantities. It tells you what, in fact, the table is showing. So in this case, we'd have position and time, those two quantities in the table. And we want to give a little bit of a description. So perhaps for a trip home, because Surfing Bob was driving home from work. So position and time for trip home. Okay, now what we're now going to do is we're going to take the information here, that position and time, and we're going to be transferring that over to a graph. So just a couple of pointers when you're doing graphing. You want to make sure that the graph has a title. You want to label each axis, so we've done that already. You want to select an appropriate scale, label the graph, plot the points accurately, and include a descriptive title again. So we're going to look at each axis and what it represents. When we do position time graphs, we always have time as the x-axis. So in this case, time is in hours, just like it is in the table. We also have the position on the y-axis. In the position, we have it there. We have the unit in brackets, and we should also have the positive direction. So in this case, the positive direction is going to be north. So we'll just have north over there. We forgot to include that. So what we have so far, we've labeled it, and we've done the scale. We've plotted the points accurately. That's already been done. So when we look at this, the thing is we still have to include it as a descriptive title. Now normally when we do graphs, unlike data tables, the title of the graph should be underneath, and it should be underneath the graph, and you start with figure. So it'll be figure. It's our first graph, so we can call it figure 1. And what we want to do is we want to try to use the same title. So if you recall, we used the title we used for the table up here was position and time for a trip home. Well, it's the same information. We're just presenting it in a different fashion. So what we can do is we can use the same title down here. So it'll be position and time for a trip home. And I know it's a little bit tight, but we can still squeeze the title there. And as whenever we have a title for a figure or for a table, we should always underline. So let's underline that with a ruler. There we go. Now, with regards to the graph, we always want to draw a line of best fit. Now, remember, a line of best fit best represents the data and tries to incorporate as many of the data points as possible. So I'm going to go here and place my ruler on top and draw a line of best fit that I feel really represents the data. So here's my line of best fit that I'm drawing. There we go. And you can see it does go through the origin over here. Now, again, this is an average of the data. So you notice that some of the points over here are actually not on this graph. So it's important to recognize that. So you're not going to be, when you're calculating slope, you're not going to be including these points for your slope. So the next thing we should be doing is looking at the actual slope of this line. So to do that, we're going to select 2 points. So I'm going to select this point over here. And I'll try to find another point that is easy to read off of the graph. Looks like here's a nice point right there. So you can see this one and this one are very easily read off the graph. And what I'm going to do is I'm going to put a little dashed line here. And this dashed line is going to enable me to show you the actual values, the data points of the graph. So down here you can see that for my x value, we're at 7.5 seconds. I'm going to put this over here. So 7.5 seconds is my x, and my y over here is going to be 40 kilometers north. So I'm going to put that down, 40 kilometers north. Again, don't worry about significant digits. We're just reading off of the graph. Don't have to worry about them. Down here it's quite easy. We can see that we've got 0, should be hours actually, and 0 kilometers. So let me just change this to hours for the unit for time there. Now, when you're doing the slope of the line of best fit, remember that what we do is we find the rise over the run. So slope, and in this case, it's going to be equal to the change in the y over the change in the x values. So I'm going to use my 2 points here, and that's why I included them here. So my first point in the y over here will be y2, and this would be y1. So y2 minus y1, which would be 40 kilometers north. And in this case, my y1 is easy. It's 0 kilometers. Now, for my x values, let's look at here. So this would be my x2, and this is my x1. So my first point and my second point. So here, x2 minus x1 would be 7.5 hours minus 0 hours. And when we calculate this out, we're going to get, let's see what value here, around 5.3, I believe, kilometers per hour. And the direction, we want to include the direction here, north. So basically, by finding the slope, we've actually found the velocity of this particular vehicle. And if you just go to the bottom now, let's scroll to the bottom of this page, this is exactly what you're going through. So the steepness or the slope of the line, what it represents the velocity. So I'm going to put this down here. So the slope of a position time graph is your velocity. So in other words, the velocity is equal to the change in the y. In this case, the change in the y happens to be my change in position. And my change in the x is my change in time. So again, slope of this graph gives you your velocity. And this is going to be important later on when we're dealing with equations. So that's it for this first part. I'm going to continue in the next segment.